Hi, in this lesson we are going to look at Chapter 2, Section 1. It talks about functions and their graphs. Basically, it should be a review of some college algebra skills. So the objectives we have is we need to know how to evaluate a function, evaluate a piecewise function, find the domain of functions, and graph a function. So let's start out with the review of evaluating a function. So we're given f of x is negative 2x squared plus x minus 5. What you really want to be careful about here is this negative sign and order of operations. But let's just go through the basics. What does find f of negative 3 mean to do? Well, negative 3 is going to take the place of x. So we carefully fill in negative 3 everywhere there is an x. And again, just be careful of order of operations. You are welcome to use a calculator, a scientific calculator, but this should be fairly easy. So again, order of operations say I need to square that negative 3 and make that positive 9. So I have negative 18 minus 3 minus 5, and I believe that is negative 26. All right, so the next one we're going to look at is f of 0. That should be a little bit easier because multiplying and stuff by 0 is always just easy arithmetic. So same process. And I'm going to just use some mental math because 0 times anything is 0. That's 0. That's 0. And so what I have left is, of course, negative 5. All right, so let's do one more numerical example. And I believe that is negative 6. So we've done 3. Now, what happens when we are asked to substitute in for x another letter? Well, it's actually easier than the numbers. So let's take a look at that. So if I want to find f of a, again, just like I did the numbers, in place of x, I'm going to put an a. And order of operations, that's a squared times negative 2, and an a and a negative 5. There's no like terms, so we just leave it like that. Actually easier because no arithmetic. Now what about this negative a? Well, just like back here, we just need to take care of the negative signs. So order of operations, I need to square that, and that's going to become positive a squared times negative 2. And so if you wanted to notice, there's not much difference between those two answers except for the middle term. That first term, the a was squared, so whether it's positive or negative came out positive. All right, so hopefully you should feel comfortable with that concept. Right? Well, what about piecewise functions? Most students kind of get a little bit scared about those. It's just two functions in one, but what you have to watch out for is the domain restriction. Remember, the domain is the x values. And so basically, this says you're going to use the first part of the function if you have a domain of x is less than 1. You're going to use the second part of the function if x is greater than or equal to 1. All right, so it asked me to find g of 0, so I look at 0. Well, is 0 less than 1? Yes, it is. So that tells me I need to use the top function, and again, replacing x with 0. So 0 times anything is 0, plus 3, of course, is 3. Right, so let's look at g of 5. Well, let's see, 5 is not less than 1. 5 is greater than or equal to 1, so I need to use the second function. So that's the square root of 9, which you know is 3. Coincidental that the first two examples both end up with 3. All right, now g of 1. Well, that's the tricky one. That's the one they always try to think, ooh, I'm going to get you. Well, look, you've got to use this one right here because it says x is greater than or equal to 1. Well, I've got 1. So again, I'm going to replace x with 1. This is the square root of 5, and just stop there. Don't pick up a calculator and get a decimal. That would just be an approximation. All right, so now let's do the last one, g of negative 2. Where does it fit? And your question is it less than 1 or is it greater than 1? Obviously, it's less than 1. So I use the top function. Again, being careful of order of operations. So I'm going to square this before I multiply. And of course, negative half times 4 is negative 2 plus 3. Oops, is a positive 1, I believe. The next thing you need to be able to do is you need to be able to look at a graph and answer some questions. This is, again, something you should have done in a previous class, college algebra, or even before that. And so really what you want to look at this is ordered pairs. These are your x values, and it's asking for the y values. So you're going to go to the graph, and it says, okay, when x is 0, which is right here, what do you have to do to get down to the graph, and what's that y value? Well, I believe it's counting in ones, so that is negative 2. Okay, so now we're going to say when x is 6, so we're going to come out here on the x coordinate, right here at 6, and we're going to say, all right, well, if I come up here, what's that y value? And I believe that is 5. In other words, you could write that as an ordered pair of when x is 0, y is negative 2, or when x is 6, y is 5. Now, keeping that in mind, we're now going to go backwards and say, okay, they're going to give us the y values, and they want to know x. In other words, here's my x, but y is 6. They want to find that. So we look here and we go on our y-axis and say, okay, y is 6. Now, where do I have to go? Aha, I have to be at 5. Okay, and on this one, again, this is x, this is y. So go to your graph, and you're going to go to the y value of 0. Remember, this is your y-axis. And where does the graph? It is at 2. So look at those two coordinates, 5, 6, and 2, 0. Do they exist on the graph? All right, so now we want to look at the domain. And remember, those are the x values. So you want to look and see how far left and how far right your graph goes. Okay, so again, this has kind of gotten a little bit messy. So let me kind of erase some of this. Okay, and so as I look at the graph, what is the furthest left it goes at negative 1, and then it goes all the way to 9. And since those are filled in dots, they are included. So writing it in what's called interval notation, you should be familiar with that, is from negative 1 to 9. Or another way to write it, more traditional, is with the inequalities. But you really need to be familiar with that notation. All right, range is the y, and the most complicated part about this is that you want to go from bottom to top. You want to go from low to high. All right, so the lowest the graph goes looks like at negative 2, and again, we're looking at the y values all the way up to positive 6. And another traditional way to write that would be with your inequalities. But again, please use the interval notation. Now, some of the hardest things that you may have done in college algebra, probably a little bit fuzzy in your brain, is how to find the domain. You assume the domain to be all real numbers, unless you have rational functions, which are fractions, or radical functions, actually even radicals like square roots. All right, so And the rational functions, you can never divide by 0. But first of all, let's look at this example. F of x equals x squared plus 3. Is it a fraction? No. Does it have a square root? No. So you don't have to do any work because this is all reals. And the way you should write this is from negative infinity to positive infinity. And this time you want to use parentheses because you never can equal infinity. Okay, now let's look at g of x. What do we have? Well, we have a fraction. So we're going to go back up to here and read the directions. And it says that we need to set the denominator not equal to 0. And we need to solve for the variable. And these are the values that the domain cannot contain. So that says x can be anything you want except for -2. Now, the way you're going to have to write that or on the computer would be interval notation. So from negative infinity to -2, and then -2 to positive infinity. Notice I put the parentheses saying it gets as close as you can get to -2, but not ever touching. All right, the third example, we have a square root. So we're going to look at this, and it says you want to make sure it's real numbers, so not imaginary. All right, so what do we have to do? We want to take what's underneath the radical and set this expression greater than or equal to 0. So we have 2x minus 5 greater than or equal to 0. Now why we do that is we're saying if I take the square root of something bigger than 0, I don't have a negative. All right, I won't have an imaginary number. All right, so I'm going to now solve for x. This is what x can be. It says x is everything that's greater than or equal to 5/2. I just want to visualize that on a number line. It says this number and beyond. I can use all of those numbers. I cannot use anything to the left of 5/2. Go ahead and try it. Plug an x in and see what you get. You will see that if you plug in something less than 5/2, you'll get the square root of something negative, which is not what we want. All right, so how would we write this? We would write that from bracket 5/2 to positive infinity. Okay, let's look at these next two examples. So this is a square root. So it says take what's underneath the square root and set it greater than or equal to 0. But stop for a moment. The idea is we want this to be positive. Well, I'm adding 7, that's positive. I'm multiplying by positive 4, that's positive. Well, what happens when you square a number? That's always positive. And positive numbers are always greater than or equal to 0. So you don't really need to do any work. The domain is all real numbers. It doesn't matter what you stick in there for x. You're always going to get some number greater than 0. Okay, so this example is to remind you of what that means. All right, remember the bottom number is the root and the top number is the power. So another way to write g of x would be 5 times the square root of x plus 3 cubed. All right, so this has a square root. It's kind of hidden in that exponent. And how do we find that domain if you have a square root? It says what's underneath the square root. We don't care about the 5 or the cubed. What's underneath the square root, set that greater than or equal to 0 and solve for x. That's your domain. And you would write it in interval notation. These examples should correspond very closely to the ones that you're having to do within the WebAssign computer. Okay, these next two is to sketch the graph and to find the domain and range. There's a couple of different ways to do this. You could remember from college algebra the basic graphs and the translations and stuff. If you don't remember that, you could plot points. And so that's what I'm going to do. And yes, you could grab a graphing calculator, but most likely not going to be allowed on the test, so don't get into that habit. So if I just wanted to make a table of values Well, first of all, what is the domain of that? I know since it doesn't have a square root or fraction, it's all real numbers, meaning I can pick anything I want for x. So I think I always like to start with 0 because it's easy. So I would get 4. And let's see, how about 1? So 1 squared plus 4 is 5. And how about negative 1? Well, if I square that and add 4, I get 5 as well. And let's try one more. So 2 squared is 4 plus 4 is 8. So kind of running out of graph paper. And you would get the same thing as negative 2. And hopefully you kind of remember from college algebra that that is indeed what was called a parabola. Okay, so looking at that, the domain is all real numbers, and we could have known that from the graph or just the function. But the range, remember we want to go from low to high, from the lowest y value to the tallest y value. So what's that lowest y value there? I believe that is 4. And it includes 4, and then it goes on up to infinity. All right, let's look at this next one. We have a square root. So the domain is not all real numbers. In fact, what do? We take what's underneath the square root and set it greater than or equal to 0. So as I build my table, I'm going to start out with negative 2 because that's the smallest thing x can be. So if I plug in negative 2 for x, negative 2 plus 2 is 0. The square root of 0 is 0. Now, what else can I choose? Numbers bigger than negative 2, like negative 1, 0, 1, 2, 3, things like that. Okay, so if I plug in negative 1 for x, negative 1 plus 2 is 1, square root of 1 is 1. Plug in 0, I get the square root of 2, this is the square root of 3, this is the square root of 4, which is 2, and so forth. So hopefully you can see the pattern. So I'm going to plot these points. And you could get an estimate or just skip to the number that you know. And hopefully you have done this type of graph in college algebra. So if you knew how to do it without plotting points, if you knew just to shift it to the left, that's fine. Okay, so this is the domain, and you could do that from the graph as well. So we want to go from negative 2 to infinity. And again, the range is the lowest y value to the highest y value. Now this graph is going to keep getting bigger and bigger, slowly, but it does get there. So it would go from 0, because that's the lowest y value there, all the way up to infinity.